Automation can make things as easy as clicking a button. But behind that simplicity, there's usually a mountain of work. And if you don't get it right, that mountain could be a volcano waiting to erupt. You want to get it right. You're not looking to make life harder down the line, so you want to be picky about the tooling and take the time to learn to do things the right way. But then you actually have to do the thing on a regular basis. This episode, we hear the story of an engineer at Cox Edge and the work he and his team have done to make automation almost second nature. It requires taking a hard look at what their actual processes are, blocking out the steps, scripting them, accounting for unusual cases, and most of all, accounting for human error, because nothing is ever truly completely automatic.
Automation is wonderful because it will update thousands of things at a time. Automation is also very scary because it will update thousands of things at a time.
Josh Bradley is the Director of Technology and Security Operations for Cox Edge. He's been at Cox for 25 years, and in that time has helped get their automation program up and running. People know what's possible with automation, and so when it's absent from processes, the ensuing delays can seem interminable.
The developers were always thinking we were taking a long time because it would take 2 or 3 weeks before we could even start our work. So what we were really trying to do is, since we didn't have control over that realm, is to take control over our realm and really automate and streamline anything that we could for our side.
Josh was setting up the infrastructure for developers to be able to do their own work. It was complicated and depended on the cooperation of other teams, which slowed things down. Over time, automation helped with that. But it takes a lot of effort to get to that consistency, to meet compliance requirements, and to improve security. It requires being thorough, which takes time. Unfortunately, not everyone knows how complicated setting up an automation framework can be.
Generally, someone's introduction to automation is, okay, you're going to automate this thing. Well, why is it taking several weeks longer than when you didn't automate it? I thought automation was faster. So it's really just making sure that your customer understands that end goal of, yes, this will take longer up front, but I promise you down the line, you'll save hours and days on things. Yes, the first time is going to be a little longer and painful, but as you get that automation practice down and you kind of get the flow of knowing what needs to be automated and in what order, then all that stuff gets streamlined.
As with many skills, there's a learning curve to adopting automation. It can take a while to get the hang of it. Hopefully, you spend less and less time learning the tool on each subsequent project. But at first, you won't save any time when automating processes. That time saved comes later. And in the meantime, there's a heap of preparation to do.
The automation takes longer, the first time, because you're not only doing the manual config, you're then having to turn around and automate that. So there was some initial hesitancy around, wait a second, you said you were going to save us time, but now you're adding time to be able to do that. But what really came into play is when we were able to do the additional environments, or they said, okay, now I need a production environment. And well, 2 hours later, they had that environment.
Processes go from weeks to set up an environment to taking a couple of hours. It's difficult to argue against that kind of time-saving work. It's just that the road to get there may have been a little longer and a little bumpier than expected.
That's really when the value came into play and really where it became a requirement, because people no longer wanted to wait for those additional environments. They wanted that push-button experience. So we got ourselves into that situation by providing that service that people wanted to use. But again, it's automation is one of those things that most everybody gets value out of. So, after you get over that initial stand-up hurdle, it's pretty easy to sell.
Getting over that initial stand-up hurdle is the trick, as is getting everyone to understand that the stand-up is complex, unforgiving, and potentially treacherous. Okay, yes, that was a little dramatic, but a little caution will help in the long run when automating updates for thousands of components at once. There's a lot to account for, even for temporary requests, especially for temporary requests.
What's really valuable is we can turn those into additional environments. So, for example, if a QA team comes and says, hey, I need a low test environment, only need it for 2 weeks, 2 hours later, we've got them an environment stood up. They can use it for as long as they need it. And then, when they're done with it, we just reclaim the resources and add them back to the pool.
Standing down environments and reclaiming those resources can be easily overlooked. How many times have the operations team had to investigate which of the cost-draining environments are still in use, and which are sitting idle and running up unnecessary bills. Making it easy to turn those off is an easy win. It's one of many. After years of experience, Josh's team has a simple rule to rack up those easy wins.
Our rule is if we have to do it more than 3 times, it gets automated. Once or twice, not, worth the lift really, but 3 times, that's when we get the value out of it. We do the manual once approach just to help with complexity. Automation adds time and complexity on things. So, we do the manual approach first, get it all working, prove it out. We don't really want to waste time, automating something that won't be part of the final product.
Talk about having automation become part of your work culture. They not only identify when a process is going to be repeated, but also quantify whether that repeated process is worth the effort of automation. It takes experience to make that determination. Josh shared what a typical process ripe for automation looks like.
Days to a week, just every little component, and you get that and make sure that gets working, and then you move on to the next component and make sure that gets working and then move on.
And the difficulty of the task depends on the makeup of the system.
The more components and the more wiring of those components, the more complex it is, just because, again, you have to get all those components working first before you can start the automation.
That may seem like a straightforward idea, but the relationship between complexity and components is not necessarily linear, and getting all of those components working with each other can be a challenge on its own. That's especially true of distributed systems. These days, cloud-native environments often run on Kubernetes. Josh and his team set up an automation process they could reuse for a multitude of cloud-native projects. With the tech world moving so much to the cloud, that reusability is a big time saver. And if you're not familiar with containerization, container orchestration, and microservices in general, here's a quick peek at the components involved.
All the complexity of standing up in Kubernetes, we didn't really have to tackle that as part of that automation. We did do that as part of a previous automation. So we worked really hard. As you know, Kubernetes is a very complex environment. And really, when people say Kubernetes, there's like 12 different technologies underneath that to make up the Dockers and Grafanas and all those bits that are needed to power really a Kubernetes environment.
Knowing all the different components needed is no small feat, let alone which options to choose, how they interact with each other, what configurations are needed for them to play nice, making sure the security policies are set up right, and on and on. You can see how automation would come in handy, but also what could go wrong.
So those were taking us days and days and days to do. So knowing that, hey, we want a repeatable process. We want our dev environment to look just like our Q environment, to look just like our production environment. We automated Kubernetes to the extreme, and we really had it down to 2 hours. And that was literally from the time that we would get the VM to production level monitoring, like integrated with the NOC, full monitoring. We could see exactly what that cluster was doing, but we had that down to 2 hours. And most of that really was the patching of the operating system.
Cloud-native environments are particularly tricky to set up, especially when specialized hardware is needed for its particular set of skills.
A good example is our Cox Media arm had to do some video transcoding, and they had a very specialized processor to meet these exact streaming demands. So those boxes were like $30,000 a piece, so pretty expensive to have a large SDLC environment. So what we did is we worked with them, and my team set up some automation. And again, it was Kubernetes focused, so we turned all the expensive nodes into worker nodes. And then when we needed to do some development testing, we actually had automation that did a role swap.
Changing the role of that hardware was costly and time-consuming, which meant development for that part of the business was limited too. With Kubernetes and an automation framework, Josh and his team were able to make those transitions faster and more reliable.
So literally, the customer could go in and click a button and put in a number. Hey, they had like 30-something boxes, so they could say, I want 6 of these to be in my QA environment and these 6 to be in my development environment and the rest of them to be in prod. And they would enter those numbers and click go, and literally the pipeline would go execute. It would take the worker nodes, put them in the right environment, make sure they were in the right network, had the right user access, and then really complete that deployment integrated with monitoring and everything.
With a couple of clicks, that web of complex Kubernetes components is rearranged to meet the demands of the development team without interrupting uptime. And those threats to that uptime could be efficiently dealt with too.
And then when the user needed to, all of a sudden they had a big production demand where they needed to all those workloads back. They didn't need to talk to us at all. They literally just went into the pipeline, put in the number, hit go, and then all of a sudden they had the production environment size to what they needed.
From production to development and back again. A successful end result to automation, which took time and deliberation to get right. But no automation system is completely infallible, even when set up correctly. There's always the chance for user error. When we come back, examples of when things can go wrong.
Hi, I'm Mike Ferris, Chief Strategy Officer and longtime Red Hatter. I love thinking about what happens next with generative AI. But here's the thing. Foundation models alone don't add up to an AI strategy. And why is that? Well, first, models aren't one size fits all. You have to fine-tune or augment these models with your own data, and then you have to serve them for your own use case. Second, one and done isn't how AI works. You've got to make it easier for data scientists, app developers, and ops teams to iterate together. And third, AI workloads demand the ability to dynamically scale access to compute resources. You need a consistent platform, whether you build and serve these models on-premise, or in the cloud, or at the edge. This is complex stuff, and Red Hat OpenShift AI is here to help. Head to redhat.com to see how.
You can spend hours writing the docs. You can spend more setting up the scripts. But you can't always predict how people will use them, if at all. Josh learned that lesson the hard way.
So we had one service, and it was multiple different technologies. It was very complex. So the doc was admittedly very long just due to the complexity of the service. So I put it together, very detailed, and I handed it over to the operations team.
People complain about the lack of documentation, or about its quality, or lack of detail. Josh put in the work to give the people what they want and need.
Well, a week or so goes by, and so one of the ops team stops by my desk and says, "Hey, listen, can you spare, a day or so to come help us do this install?" So I was like, well, I'm happy to help, and I can share the install doc that should walk you through everything. If there's any issues, let me know. And they said, no, I've got the install doc, but that thing's way too long. I'm not going to sit down there and read that doc and follow that. So it just kind of put me in a spot of, we do all this work to get this in a spot to where it's great for them, but then all of a sudden we don't want to turn it into a lot more work for them to do.
Apparently it was too much to do. They didn't have the time to work through the doc and set the system up themselves. So instead of saving time, Josh ended up having to help them through it anyway. And that led to a pivotal decision.
That led us into the first automation. So we had to run with that service as it is, but learn a lesson there. So it kind of moved into the next automation or the next service deployment. And so at that point, I knew I was going to automate that thing, to make it easier for me and the operations team in the log room. So I wrote everything in VI at the time. We didn't have the nice Ansible tools like we have now. So I wrote it all, had scripts out there, and I had a initial configuration doc that they needed to follow to set up the initial environments. Put in the config files. Production has different IP addresses than non-prod. So there's some things that resource would have to update.
That was the beginning of his automation journey. But he wasn't done learning about the pitfalls of user error. Sometime later, the operations team was trying to run through the process Josh had set up for them. He thought he had left them everything they needed to succeed.
Of course, I was out on PTO when the production team got the VMs to their install. And I got a frantic call, help, we've got a deployment, your automation's not working, it's failing all around. So I always bring my work computer with me, of course.
Of course.
I jumped online to help them, and so we went through and I opened up the config files and they were all blank. So immediately I was like, well, I think I figured out what's going on. And I was like, well, you missed doing the config files. And they were adamant. Nope, follow that doc exactly. We updated every config file. I put it in there. There's something wrong with the automation.
Hear what he said? They followed the doc exactly. Let's find out where the stumbling block was.
So I was like, well, let's go through the doc and fill out one of these config files. So the resource went through, they added the IPs, added everything exactly as was supposed to. Said, all right, that looks good. Let's move on to the next file. So they close the first file and the window pops up and it says, would you like to save what you're doing? They clicked no and shut the file down. So I was like, well, wait a second. Hold on. What you didn't save that file? And they go, well, your doc didn't say to save the file.
I couldn't believe it when I heard it. And I'm sure Josh couldn't either. Maybe you can, if you've been in this industry for long enough. Josh realized he had a little more work to do, because you cannot account for everything.
Automation is great, but you really got to be careful with, the instructions that you provide to both the executor and the automation itself, and to be very particular.
Amen to that. There are so many things we take for granted that we overlook in the instructions. It might not be as obvious as hitting save on a file, but a lot of things that are obvious to you may not be for the end user of the process you put together. So when we say the process needs to be deliberate and detailed, this is a big part of that.
It made me really take a look at the automation that we were doing. And yes, hey, we thought this was very user-friendly, but it wasn't as user-friendly as I thought it would. That's what we really took it to, is it was bare minimum user input for anything. It's only the exact required bits, and then the scripts took care of everything else, including saving the files.
The more sophisticated our automation tools become, and the scripts we write with them, the less we need to account for user error. But this is a reminder that there is always something that the user can misunderstand, or straight up get wrong. That's when one process in particular can come in handy, and hopefully you've got that process automated as well.
That's where we really tout rollbacks. Working on something at 3 a.m. is very different than working on something at 3 p.m. So we really try and get the production teams, hey, if you do run into an issue during this deployment, roll it back, and we'll all get together the next day, get multiple people in the room, not just whoever happened to be on call, and be able to troubleshoot that. Of course, if it's a production service that has to absolutely be deployed, then of course we're happy to get on and troubleshoot. But you really still need somebody that knows the automation side to be able to help troubleshoot those. But again, once you've really QA'd your automation, it's generally some kind of environment difference from a manual update or the code issues that sometimes happen.
Automation is great. Automation is complex. And automation can absolutely go wrong, even when it's gone right many times before. Some change somewhere can have an unintended effect. Have that rollback option set up to be rock solid, just in case. Josh and his team are by now experts in automation, and they're able to share that expertise more widely.
We collaborate a bunch, but we're not like evangelists or things that go out. But my previous team, we were Kubernetes focused, and so we were very, very automation heavy on that. So we did set a lot of the standards for some other teams, and as part of that, they were seeing some of the cool things that we were doing, so we got some adoptions through that way. But it's really just collaboration across the company that really got us to where we are.
We just spent an episode talking about the importance of getting automation processes set up correctly to minimize the chances of human error. Josh and his team refined their automation processes, but they're one small team in a large organization. They can't take on the whole company's automation projects. Next time on Code Comments, we hear from a small team of internal consultants at Ulta Beauty and how they help the rest of their company help themselves. You can read more at redhat.com/codecommentspodcast or visit redhat.com to find out more about our automation solutions. Many thanks to Josh Bradley for being our guest, and thank you for joining us. This episode was produced by Johan Philippine, Kim Huang, Caroline Craighead, and Brent Simoneau. Our audio engineer is Elizabeth Hart. The audio team includes Lee Day, Stephanie Wunderlich, Mike Esser, Nick Burns, Aaron Williamson, Karen King, Jared Oates, Rachel Ertel, Carrie De Silva, Mira Cyril, Ocean Matthews, Paige Stroud, Alex Trabulsi, and Victoria Lawton. I'm Jamie Parker, and this has been Code Comments, an original podcast from Red Hat.